Hi there, Mustangs. How are we doing today? Uh, Today, we are going to be working on how to clear out fractions when we're solving fractions or inequalities. It should say equations instead of fractions, but same thing in terms of what we're doing here. We're working with fractions that are in equations or inequalities. Anyways, what we're doing is we're trying to figure out what's the best way to tackle problems that have these annoying fractions in them so that we don't have to actually have them in the problem anymore. And it all comes down to a process called using the least common denominator. So what we're going to do is we're going to look at the least common denominator of the 4 and the 6, okay? And really what we're saying is what's the least common multiple of 4 and 6? If we look at the numbers 4 and 6, that's a very chunky thing there. Think about, first thing you do is you can just use 24 because that's just multiplying the two numbers together. But even easier than that, there's a smaller number we can use, and that would be a 12. Okay? The least common multiple of these is going to equal 12. Because 4, 8, 12, and then 6, 12. So if we look at 4, 8, 12, and then 6 and 12, we're just looking at multiples. We do run into 12 first. If I was to continue, we'd eventually run into 24. Still works, we're just going to use bigger numbers. Well, what is it that we actually do with this now? What you do is you take each one of our individual terms that we have in this problem. So when we say terms, we're saying this entire part right here, it counts as one term. This entire part right here counts as a term. And this right here will count as a term. And what we're going to do is we're going to take each one of those and we're going to multiply it by that least common denominator. So, or the least common multiple, which is 12. So if I'm going to do that, we're going to just throw a 12 on there. We're going to throw a 12 on there, and we're going to throw a 12 on there. And what we're doing is multiplication for each one of these. Now, if you think about what this means, that means that in our problem, we now have 12 on top and then a 4 on the bottom. So if we just simplify that, that means that we're going to have a 12 on top and a 4 on the bottom. That means we're now going to have a 3, and then it's just 2x plus 3 from there. Okay? If we look at the next part of the problem here, we've got a 12 on the top and a 6 on the bottom. What that means is that we've got 12 over 6, which means we now have, don't forget the minus sign right there, we now have a 2. And you still have that 3x minus 5. Now the mistake that people usually make is forgetting to do it to the right side of the problem. So if we continue with that, 12 times 10 means that we're going to have 120. That's it. The fraction is now gone. We don't have to worry about it anymore. And now we just continue on with our method of solving. Let's distribute first. We have 6x plus 9 minus 6x plus 10 is going to equal 120. Okay. Combine like terms here. These are going to go ahead and actually cancel out, leaving us with 19 is equal to 120. And in this example that we came up with, since 19 does not equal a 120, we would say that there would be no solution for this. Okay. All right, let's take a look now at this second example, which has now inequalities. The process is not going to change at all. But what changes here is that we have 3 numbers in the denominator rather than just 2. So when we're looking at this, we have a 3, a 5, and a 10. And you got to go through and figure out, well, what's the least common multiple of these? So if we look at 3, we've got 3, 6, 9, 12, keep going. And then 5, 10, 15, keep going. These are the multiples of these numbers. And then 10, 20, 30, and keep going. Now the first one we actually run into where they have this, where they're in common is 30. So what we're going to do now is we're going to take and we're going to look at each individual term. So these are the 3 terms that are going on here. And we're going to multiply each one of those by 30. Okay? So I'm going to throw a 30 on here, a 30 on here, a 30 on here. And what that means is that now we've got 30 divided by 3, which is 10. And you've still got that quantity, x minus 1. We've got greater than 30 divided by 5, which is 6. And then 2x plus 4. And then 30 divided by 10, which is 3. And then times 7x. There you go. The fractions now are officially gone. We can just go ahead and just solve like normal here. So we get 10x minus 10 is greater than 12x plus 24 minus 21x. We'll go ahead and combine our like terms. We get 10x minus 10 is greater than negative 9x plus 24. Move the 9 over, we end up with 19x. Move the 10 over, we end up with 34. Divide by 19, we get 34 over 19. Doesn't matter that we don't get a clean, perfect answer. It still is a number, doesn't matter. If we were to graph this on a number line, we would have 0. We would have 34 over 19. We would use an open circle, and it would go to the right. If we were to use intervals, we would actually go ahead and do a parenthesis instead and go to the right. Same thing. And then in interval notation, we would go ahead and say 34 over 19. And it goes up to infinity and wrap around infinity because this is a half open function or inequality. I hope that helps. Oh, and don't forget, like and subscribe to my YouTube channel.